if I go to 2, this combination right here where it says silo selected, can you see my cursor circling?
Yep.
All right, right in there, as soon as I hit the silo select button, the lights are going to switch upstairs, and that's the same 2 contacts. That normally closed contact there is a made this one here. And this open one here is the same as this open one here. So when that changes, like now, you notice that all of a sudden everything here stopped. That's because when we can't get the main slat to go on until we get the transfer slat. And once we turn the transfer slat on, you see how that made there?
Yeah.
And that allows power for the drag slat and the dryer to run.
So Steve,
Now we were saying, go ahead.
on this schematic here, where's the on and off switch?
The control power is clear up here where I'm circling control power right
Oh,
now up by
okay.
line 2.
Yes.
You see how that killed the
Okay.
whole circuit?
Yes. Okay.
And actually, this is after, this would be like your circuit breaker on the wall there, where you're getting your control power from.
All right.
And then yesterday, we were talking about if the drag slat was to kill on its overloads. So you see where I'm at on the overloads over there
Yes.
on line 6? All right, I'm going to chop it out now. And as soon as that overload killed, you see the drag slat kept running. The drag and the main silo, the dryer and the main slat both went off. And here, that's all we did there. Once I fix that, we've got power up to the bottom of that coil again, at least the neutral power. Well, we'll turn it back on by hitting the main slat on, and it runs, and we get everything running now. And actually, I probably should have 2 more open overloads in there because there's one for each phase. It was simpler in this drawing just to put one of them and represent all 3. Did you understand what I was saying the other day about being in parallel and series on starters? Hello, world.
Are you
It's an
talking to
open
me, Steve?
question. That's an open question.
Oh, okay.
Yeah, I guess
Yep.
as far as parallel makes a little makes sense, but I'm a little more curious on the series.
Okay. Let's go down here. Delete this contact. Delete that wire. Delete. Come on. Delete the rung. Delete the rung. Delete the wire. Delete the wire. Come on, over here and delete wire, people. Now, we'll go here to where I want to put something in. Click over that way. Contacts. 1, 2. All right, now those contacts are both in, all 3 of them are in series. It goes from one to the other to the third. The light bulb down here and the dryer motor are in parallel.
Parallel. Okay.
Now, what I was talking about before was that if we had multiple starters for that dryer, um, it would then go and all work together. Let's Move the light down down to there. Nope, no people. You want to make that just normal. Delete the switch.
It's Steve, it's 9:09 now. I can give you till 9:15, okay?
Oh, that'd be more than enough. Thank you, Clarence.
Okay.
What happens, guys, what I'm going to do here is I'm going to take quick and drop some extra starters in here. Where this little button is here, we'll take in, we'll go to motor starters. Number 2.
So now you're putting all these starters in parallel?
The starters are in parallel, and what I'm going to do next is I'm going to take and put all my contacts in, except delete that one. And this one here will drag this down to here. And you actually have got them in for all the motors, not just for one motor.
Okay, so if it were just one motor, you typically do that as a series then?
The motor coil to the overload stays in series. However, when you have multiple motors, let's say I've got a motor on each part of the drum here,
right? Yep.
You then end up, you put all the coils parallel like this, and imagine that line is longer than just those 3 that I've got on it. That it's actually got, say, 4 or 5 of those coils, or actually 12 of them all in a line.
Okay.
You come off of one starter and go to the next starter, type on down through. And we can get just a little bit cute here with the dryer one, because I'm parallel to the coil. I can put it in there like this. Oh, no. Sorry for doing this on the fly, but it should look pretty interesting here in a minute. We'll go up here, we'll turn the power on. Give our control power on. We'll start the transfer slat. We'll start the main slat. Then I'll pull on down here, and let's watch these starters pull in. I'm going to hit the dryer. And when I hit the dryer, you notice all 4 of them pull in, plus the light comes on. But if any one of those 3 overloads drops out,
they'll all shut off.
Yeah, and actually any one of the 12 overload drops out, we'll just go kill one of them quick. Everything in that circuit kills.
Okay.
And as soon as you reset the overload, you can restart the dryer. That's a common one you're going to see on any drum that's running 4 electrical motors or such. They'll pull, if they've got the separate motors, they'll pull them all in alike. And if they run one big main starter, you're still going to see a set of overload coils for each dryer. In other words, they might have one great big size 7 contactor in to start and power all 4 motors. But the overloads will be still the 4 separate little overload blocks with the 3 overloads each in going out to each motor. So I will stop my share so that Clarence can have it back.
Nice job, Steve. Thank you very much. Let's have a round of applause for Steve. Thank you. That was nice. Okay. We're going to be pulling up a certain picture, right? Right, David?
Same one you had before, Dave.
Yeah, is that weird? I did show everyone your hands-on photo there.
Okay. Okay, this is the part of the workshop where you're at right now, where this picture was taken. And so this is where the rubber meets the road. And I'm finding out that going through all that chit chat we've been doing for the last 6 hours, that when we says, okay, guys, come on, we're gonna do some troubleshooting with the circuit right here with some problems into it. They all got excited. So basically when that happens, we first of all, just like today, we review, and we're going to review the 3 different circuits. And one's that motor starter circuit we've been looking at, and there it is right there in the flesh. That we've got a light, we've got a push button, we've got a motor starter, we got inquisitive people, and we got a test meter. And notice he's got that test meter. This thing plugs into a 120 volt cord. So if you're going to set your test meter, what would you set your test meter for? This is one thing we got to ask people before you even start. What are we testing for?
AC.
So I'll go around the hoop. I'll pick up on Isaac first. What are we testing for? What kind of voltage?
AC.
AC what? Voltage, right? How much AC voltage?
120.
Okay. So it on a multi-ranging, you really don't have to set it besides voltage AC. Of course, with your manual ranging, you're going to have to put it like a 200 volts DC, because 120 is under it, and it will read that. Anything over 200 on the manual, it won't read it. So this is something you got to have prepared in your head. Isaac, what do you have at your plant? Is it a geez, I'm having a brain.
Auto ranging or manual?
Thank you.
Say that again, Dave.
Do you have an auto ranging meter or a manual meter? This one's a manual. It has a turn dial on it. You have to find
Yeah,
the
yeah.
right setting.
We have a manual.
Okay, well, they all have turn dials. You have to set it for 200 or you just put it at volts AC. Isaac, what kind of meter you got?
Manual.
Okay, we should have
So you
asked you to bring those today. You don't have them with you today, right?
I do not know.
Okay, so in your mind, if it's manual, then if it says, you'll probably set it at 200 volts DC or AC, I mean, okay? If you set it at 120 volts will be over that and you can't read it. Or basically what it says on our meter, it says 200 or 20 or 2000 or some damn thing. So you've got to set the meter. So you got to have that in your mind's eye. Let's set it first of all to the right thing. And so we got to prepare our meter, and we got to prepare our meter for the circuit. How did he prepare his meter for the circuit before he even started pushing that button?
Test the meter on a working circuit.
Okay, well, that's a good thing to think about. And so, but right now, if you were going to test it, I asked you to do the to maybe troubleshoot with one hand. If you get both hands across the circuit, high on one side and low on the other, you're going to get electrocuted. But if you just put in one, so I'm just saying it's a safety thing to do. So we're looking at the safety things, prepping you on how to be doing some troubleshooting. So you've checked out your meter, and but one way to check out your meter, but we can't really check it out quite yet, because notice what's at the end of that. I don't see it here. Do you see the he's got 2 probes there, and a black one and a red one. Looks like he's got a
There's an alligator clip on the black. It's kind of hard to see. It's a red clip.
Okay, and where does that end up at?
It looks like it's going to the clipped on the end of the other.
So it looks like he hasn't even prepared a circuit yet. Jeremy, you let him get away with that.
He was testing it after he fixed it.
And so how's that testing working for him? Oh, maybe he was.
That's why the green light's on.
Well, it depends. The symptom does, Jeremy. You're not off the hook so quick. I see the lawyer in your so anyhow, and because it's an alternating current, it doesn't matter if you you know, if you on your meter, if you use your black probe to ground, use common or otherwise. And here, basically, he was going to use his black one, and his black one should have been tied to someplace. And on those terminal strips, you see those terminal strips there where that black cord goes into? He should, there's a neutral, there's a number 2, the low side of the circuit. That and so so when he's doing his troubleshooting, he's got to be putting his lead on number 2 on that terminal. And so after he does that, then he can maybe test his meter. So if he's going to test his meter, then he'd be doing it with a red probe. So if he was doing it with a red probe and he want to test his meter, and if you remember that circuit for the motor starter, it kind of plugged into 120-volt wall. Terminal number 1 there was where the hot was. Number 2 was where the neutral was at. So Jesus, where would you put, if you wanted to test that meter to see if it's working right, with that red probe, because you've already, with that red alligator clip, clipped it through to number 2, and you just want to troubleshoot with one hand, where would you put that probe in the circuit? Do you recall that circuit? Dave, can you bring up that circuit there a little bit? It might take a little bit of time here. I think it's time I kind of refresh these guys. This is that circuit. Okay. Now I'm not quite sure if everybody can see based on their can you guys see the entire circuit? Because I'm seeing you guys there over the number 2, and I'm not quite sure how I'm going to do this.
Yeah, I see the circuit on my screen.
Yeah, I see.
Yeah.
You gotta
see it?
move. You gotta
I
move
do
the
too as
camera.
well.
Okay, so on the far side, that's number 2. That's your neutral. That's the low side of the circuit. That's where you're putting your that alligator clip that we were going to clip on. And then so Isaac was saying, well, we got to test the meter to see if it works. If we're going to test the meter to see if it works, we're going to go to a known place where we're expecting voltage at. And that terminal number 1 goes right there to that hot side of the plug. So that's a very easy place to be checking it. So if you're going to test your meter and you put your and so Isaac was saying he wants to test it out. Is that a good place to be testing out there, terminal number 1, Isaac?
Yeah, I'd say
Okay.
so.
Okay. Now, if you remember that picture that we just got done seeing, you know, we're setting up things to do the troubleshooting. Well, we talked a little bit about arc flash and stuff like that. It doesn't hurt for you to wear safety glasses, at least around, you know, around 110 volts, and anything above. And if something shorts out on you and pops, you don't want it in your eyes. So we do safety glasses. I mean, that's one of the most important things, the most vulnerable things you have is your eyeballs. So, so keep that in mind. So here's the circuit there that we've just got to testing it. And so if we can go back to that drawing or that picture again, David. So right now what had happened is he is after we first we troubleshoot, then we fix. So we put a problem into this thing here, then you guys read the symptoms. And then you guys, based on the symptoms that you know, you go to that part of the circuit that applies to that. You don't want to be checking in parts of the circuit that doesn't apply. You're wasting time. You're confusing yourself. What you don't have in your head, you make up in your feet. So this is in your head. Now, when we first start presenting you with a problem, and this is what happens there all the time when you do hands-on. When we put a problem in there, he goes in there and he checks out the symptoms. And the symptom might be he presses the start button, maybe. And then and maybe the coil pulls in, and maybe the light doesn't come on, or maybe the light comes on, the coil doesn't come in, or maybe both of them don't come on. Those things are things that you have to interpret what those symptoms are before you go into part of the circuit that applies to that. Now, the first thing that you do, and these guys were no different, and you'd be no different if you were there and you push the start button. you would see, oh, okay, the call didn't come in, but the light came on. And then they says, okay, now you know your symptoms. Instead of looking at the overhead, see on the wall up there, on the overhead projector is the diagram of this schematic. And this is the roadmap. This tells you where to go next. But guess what you guys do? Because you don't know any different, or this is the way you've always been doing it, is you look around the circuit to see what could possibly be the problem. I'm going, a lot of these problems are invisible and you can't see them. So, but if you take a look at the schematic, this here tells you what's going on. This is like reading a roadmap. How do you let you go to Alabama without a roadmap? Well, you know, that's the difference. And so understanding the circuit gets to be important. So taking the time, like Steve has done, to take you through the circuit ahead of time and say, okay, this is what we're expecting out of this and out of this and this and this and this. Okay, so then when you go do your testing and you go put your probe at a certain place, you guys got to think about what voltage you should be having ahead of time. So, oh, I should have 120 volts there. 120 volts when? Well, when I push the button. Those kind of things are important. You got to have that in your head. So when you're looking for a certain something, you want to know ahead of time if I'm looking for 120 volts or 0 or whatever we're looking for. So that when you go through the process of pushing the button and see it didn't come on or whatever it was, you know the fact that it was there or not there, you know what part of the circuit to go to, up or down the circuit. So it is a thinking process. It's a skill level. We're teaching more than just things. We're teaching you a skill. We're teaching you how to put one thing ahead of the next and stuff like that. So that pretty much. Now, if you look at the circuit right now, when you compare that to the starter and how the wires are going here and there, that's pretty jumbled up. So all of a sudden, you're looking at a circuit that's well organized, like you saw in the schematic, and you want to look at a certain spot. You're going, where the hell's that certain spot on this starter? And so we're going to do something new this time, is show the schematic and the starter side by side, so you can, in your own mind, know where you're going to be picking up your probe and probing around. And something that to be concerned about. It concerns me when I think about you guys doing 480 volts. You see that that probe there sitting on the table. I see you guys. I see many of you guys will put your fingers down there by the probe. I mean, it's like you want to mirror the damn circuit. I'm going, put your fingers at the end of the probe where the wire comes out. And this is more like remote control. Keep your fingers out of the damn circuit. So keep that in mind when you are doing some troubleshooting. One is you've got your clip lead already attached to your number 2. You're dealing with just one probe, and you just do one probe, hold it there at the end, and you poke at the terminals, and away you go. So those are the kind of things that we see when you guys are doing their hands-on. What right now, as far as we can do, is what you don't have in your head, you make up your feet. And some medicine you might get hurt, and we don't want you getting hurt. So that's the process. David, would you now take us to a circuit that has got both? I didn't know you could zoom like that. Nice.
Circuit with both. Do you mean a picture end of the circuit, or?
Yeah, the one with the starter and the circuit itself. Actually, let's go to all 3 of those starters, or the top and bottom one there. I want to show them where they can find their overload contacts. I want them to see where they can see their auxiliary contact, because when you look at all this, it's a little bit, what's going on here? Okay, so what we're looking at here is the start stop button. And that stop button is really normally closed. It's normally closed from that terminal number 3 to terminal number 4. If you can see that little wire there, number 4. Can you slide over? Okay. Back on just a little bit. I don't know if all you guys, okay, right there. So you can see, so those are the terminals there. And 3 and 4 are common with each other. They could have had a jumper in between each other. But if you follow but with 3 and 4 back to terminal 3 and 4, can you come up a little bit? I'm not quite sure you can. That you can see both those wires on 3 go to terminal number 3. So they're actually jumpered together like it is in the drawing. And then you got number 4 over there. That tells us that where we're at with that. If you look behind the stop button, there's a wire there. That's gonna be a terminal number 1. So you're gonna see 1, 3, and 4. So that's what if you remember on that drawing, that's kind of what we had. Looking at the starter itself, we got the C3798. Those are your heaters. Those are sized for your motor. The bigger the motor or the difference in the motor, those things change. And then you're going to see a little arrow there off to the left. And so that might be like a 5 horsepower motor, which is about 6 amps. And so the overloads might be good for about 6.5. So you can adjust it down about 10%. So it's at your 6 amps there and knows how to trip out. So that's what that purpose is. That little yellow button there tells you if this thing you tripped, this thing just got done opening up. And so that little yellow thing isn't sticking out, so we don't have that problem. If it was sticking out, then we can hit that reset button there right next to the white thing and push that down, and as soon as you let it cool down. The bottom number was there, T1, T2, T3, and that goes out to your motor. And so this is the, and so if you follow that up there through the heater, you're going to see it goes to some screws there above the overloads there. Can you, this is what your 480 comes in right there. So the 480 that goes, that's in there, it flows through that heater down below, and that's what kind of heats it up to a certain spot. If you're drawing too much current, it gets too hot, and those heaters will pop that thermostat. And we'll show you where the contacts are for that thermostat in the next picture, but not this one. And so now you're seeing there in that same line where we got the those screws here. That's actually those rusty looking screws are part of the contact of the starter. So there's 2 different pieces, and they get screwed together by those screws that you have right there. And the high and the top screws up there is where all that comes in. And so this is where your 480 volts comes in, and it goes to those 3 screws that are rusty looking. But right next to the 3 screws that are rusty looking on the left, you see a terminal number 3 down below. There. Oh,
yeah.
right there. Okay. That's part of the auxiliary contact. So you got 4 sets of contacts closing, 3 of them for big 480 volts. But then you got this small contact. and on the circuit that we're doing, I think we're calling this M8. Is that right? Or M9? I think it's M9. So anyhow, you had M9 auxiliary contacts. You had M9, the coil. This is the coil there. You can see a number 6 going to the right side of the coil. And if we went up a little bit more, you'd probably see 5 on the other terminal right there. See, remember that terminal number 5 that we had that went to the light and also it went to the coil? That's the wire right there. Now you see the one that we have terminal number 6. That's the 6 on, that's the 6 side of the coil. This is the one that went to the overload to that tripped out. And it had 1 set of terminals. It might have 3 thermostats, But just keep in mind, it's got one set of terminals, so that's all that's all you gotta know. And when it pops out, is gonna do it. It makes no difference to you. Between 5 and 6, those terminals there, this is a spring-loaded stator or armature in your starter coil. That's gonna slap down anytime you energize the thing. It's gonna go clop, and you're gonna know it, something happened. And then if you take your finger off the button, it should stay down if your holding circuit's working right. So David, would you take me to what you don't see on this one? We see it for, no, we can see it here. But where you see number 3, you see number 4. Can you see where terminal number 5 is, David? There for the solenoid, I mean the contactor on top.
Yeah, on the backside.
Yeah, well, show them where terminal, that wire number 4 is below. Point it out to them. You see,
Where wire number 4 is below.
okay, you can see, yeah, that auxiliary, that's part of the auxiliary contact, number 4. And it's going to a screw. It's down below. You can't see it very well, but we can see it. But we can see it good enough. And now you see terminal number 3. Can you show them where terminal number 3? Okay, that's your auxiliary contact. That's the other That's the other contact that is going to close whenever that armature pulls down on the coil. That's going to close, just like it's going to close for the 3 phases going to the motor. When that closes like that, that reports back to your circuit that we have closed the contact, and so now we're going to, and when that contact closes, it's going to close around that start button. Do you see the start button that says 3 and 4? Do you see the auxiliary contact where it says 3 and 4?
Yeah,
They're in
yep.
parallel with each other. Remember that schematic? And then we have our light. So maybe let's go back to, so now if you could, see if you can get the starter and show us the bottom of the picture of the starter from the bottom up. I want to show them where the overload contacts are.
On the bottom, there's a front, top, and rear.
Front, top, and rear. Try rear. Let's see let's see if this has got a good looking rear end. Okay, can we see it from the other angle? Yeah, okay, well, leave it right there. There's your 4 and 5. Do you see that? Okay, or there's 4. That's your auxiliary contact. Show them where the 3 is at, the 3 and 4.
Well, the 3's right here. Now the 4 is.
Oh, okay. No, we're good. Let's drop the overload.
3 and
okay,
4.
This is the auxiliary. This is auxiliary. This is the one that snaps around your start button. We call it holding contacts. Is what we do. And your 480 comes there in the top. So that's looking at it from a different angle. Now can we see it from the opposite angle? Okay, right here. Here you see that wire number 2? It's white. All our neutrals are in white. That's a typical thing. It's a typical thing that all the L1s, the ones that are hot, are black as far as color coding goes. And but you can see for that wire number 2, terminal number 2, it goes right to you can see a terminal number 2 there. There's a wire number 6 that goes to the top. this is the overload contacts. Remember, on the 6 side of the coil, we had a set of contacts. That's on the 0 side of the coil, the 0 volt side of the coil. It went to neutral. And then so from neutral, it went to a set of overload contacts. And then from that point, if it wasn't overloaded, then the neutral is felt at terminal number 6. They're on the overload, and then it goes up there to the coil. So if you put 120 volts on number 5 above, and since the overload's not tripped, that'll give you 0. That coil is going to pull in. That and we may be asking to check on the on the 6 side of the coil and the 2 side of the overload, based on what the symptoms are at the time. So now I think this probably spells out pretty much what, okay, now you got both of them up here, don't you? Okay, nice job. Oh no, we wanted to have the now pull up the if you got the starter drawing and the overhead shot of the starter itself, can you pull up that one? Not that one. If you had, are you able to put the schematic and the starter on the same?
Yep. That's not it.
We'll get there.
Okay, you seeing them both now?
Okay, I am. Let's see if I can minimize this. And now I get David. Now I get, okay, there we go. And I'll put David over here. Okay, so we're gonna look at it again. So what I'm telling you that, you guys are getting poised. You guys are being given, you tested out, you got some symptoms. And then when you see that, the first thing you're doing is staring down below at the starter. And I'm going, don't look at the starter, look at the schematic. So let me pick on Isaac for, well, let's talk a little bit about what we learned about yesterday. We said on a good working circuit, we talked about the 3 sets of 3. Well, one set of 3 was the fact that we have voltage, amperage, and resistance. Well, in this particular circuit, we got voltage is the same as pressure. So we have 120 PSI, kind of think of that way, like a pipe, there at our power supply. You had to, we also know, besides having our voltage, amperage, and resistance as far as the 3 sets of 3, we also know that it takes 3 things to make a circuit, a working circuit. One's a power supply. Well, there's the power supply, the 120 PSI coming out of your wall outlet. And so, it's a small it's the black wire on your outlets that it's got your 120 volts there. So high pressure seeks low pressure. Well, where's low pressure? Well, neutral is low pressure, that's 0. So so in order to make a circuit, you got to have power supply, you have to have the conductors. You got to get the pressure to and from the components. And what's the components? It's not the switches. Those aren't components. Those they're not loads. They may be components, but they're not loads. Loads is things that are doing the work. Well, what's doing the work in this circuit? Well, I pushed the start button. I want to see that coil pulling. That's one thing. Let's get that job done. And I want to see that light come on. And it did. So those are your loads. That's what you're going to have 120 volts on one side and 0 on the other. And those switches, we said you had to have 3 things for a circuit. You had to have power supply, and you had to have a pipe to get from the power supply to your component or to your load, and then from your load back to your reservoir of electrons so it can keep on recirculating. So high pressure, 6 low pressure. We also were talking about a series and series parallel circuit. The first series circuit you guys went through, it was nothing but a damn circle. Anything you break in it is going to stop and make it, okay. There's not much symptoms beyond that point, other than that, it doesn't work. But then we started to get a little more complicated to it, and we added another circuit in parallel to it, another one parallel to that, and then a switch in series with both the loads. And so if one load came on, the other one didn't, there's parts of the circuit there that tell you it's good because you got it to that point. And so, and the same thing goes here. So you got to keep that in mind, what we're doing here. And so we had our series and series parallel. If you look at it from the first point, what it takes in order to get the main part of your job done, the series circuit would be going from hot to 1 to 3 to 4 to 5, and then through the coil to 2 and back again. But in parallel to that coil is a light. In parallel to that start button is another switch. Okay, that start button is a conductor, whether it is connected or not. If you push the pipe, it's a broken pipe unless you push the start button. And when you do that, you're going to have something flowing through the start button. And if your auxiliary, if your drag is on, it's going to go from 4 to 5. That pressure. Now you got that pressure going to the to one side of the coil. That's a good thing because we know we have to have high pressure on one side. And then on the other side of the coil, what are we expecting, Isaac?
Low pressure.
Low pressure, absolutely. And if you get anything else but that, you can't expect that coil to pull in. So if it says 120 volts on one side and 120 volts on the other side, don't be changing out the coil. You've got to make sure it's got its proper input. Same thing with the light, 120 volts on one side, 0 on the other. So those two things are in parallel with each other. They're kind of in parallel with each other. Now that light could have been wired to the 6th side of the coil, but so whenever the coil came in, the light would come on. But this isn't how they wired it up. They wired it up right where it went to neutral. So you could push that start button and that coil maybe it wouldn't come in because the overloads had kicked out, but the light would come on. But the coil wouldn't come on, would not stay in because the dryer auxiliary coil has got to, well, first of all, it's got to pull in and then start a starter. But what else happens when you, Jesus, dryer M9 coil? If you pull that in, this is this guy right here. Damn, I got control. I feel big. Anyhow, so this is the coil right here. Where'd you go?
No, you got to accept that remote share. We can't
Okay.
see what you're pointing at.
You can't see where I'm pointing at?
No, now we can.
Okay, thank you very much, David. You're making me look good. Okay. So, moving right along, say that, say this overload is broken right here. Maybe this popped out. When that did, that means that this popped out. That means this thing here tripped out. So if you hit the start button, and if this is tripped out, you're going to have 120 volts here. Auxiliary is on, then it's going to go across here. When you push the button, the coil's not going to come in because it doesn't have connection to neutral. You don't have the 0. In fact, if you do when you do push the button down, this here is going to say 120 volts. If this is broken, Isaac, what is number 6 going to say?
That's broken. That should say 122.
Nice job. Okay, you're on top of things. Okay. Now, Jesus, when this here coil pulls in, these set of contacts here are going to close. And also this one as well. And that means that, and so when that pulls in like that, see, now we're in parallel, not with 2 loads. We're in parallel with 2 sets of things that, wires that allow you to run. See, these switches are nothing but wires touching or not touching. And right now, if you have these 2 wires touching, this here, a good working circuit is going to pull that in. And then when this coil pulls in, Jesus, what's going to happen with these auxiliary contact? This is the auxiliary contact. It says M9. It says the same thing as this coil, M9. So one says M8, that means you're a whole different motor starter away. So Jesus, when we energize this coil M9, what should this set of contacts M9 here do? Stay open or should it close? Will it close?
It should close, allowing contact. sending
Okay.
power through.
So if that closes like that, now you've got some current flowing through here. This is spring loaded. Now you can take your finger off of this thing. If you take this finger off, you say it's going to stop. No, it's not. It's going to, this set of contacts is going to flow around there and keep that coil going. So that's a little refresher on where we were at with our starter. What we did was some of the fundamentals. And so now you know the chess pieces. This is like learning chess. Oh, it's hard to learn. I know what the pieces are doing. This ain't no fun. But then after you get to know it. So we're going through a troubleshooting procedure. Then after that, we lock out, tag out, and then we're going to do things like fix the thing, and then we're gonna go back and test it, and things of the sort. So I would like to start going into a troubleshooting scenario here, but I think we should take about 10 minutes. So why don't you guys come back in about 10 minutes and I'm gonna get me some coffee. Oh, thank you. Thank you, Steve. Nice job.
That was Dave.
The reminders are huge. Thank you.
Okay, take it. You're pulling in that starter.
Yeah.
If you can do it. If it's
That's not. Make sure you pull in there though.
you didn't hear it?
Oh, okay. Never mind. You do right away.
Okay, so that's just pulling it in. Do we see it moving?
Yeah,
the
the
armature?
first second it happens instantly. Right as he's pushing it, it pulls in. You see at the top, this is what pulls in.
Yeah, try it again. Okay, so normally you can see a so that's a good working circuit. And if you want to go back to our other circuit, thank you very much. That was nice to see. A little trivia. I thought we'd hear a louder clunk.
Yeah, that's why.
But
it's pretty loud usually.
It was probably some of that cheap Colorado power or something.
Lost
No.
in translation.
You don't know what you're gonna get on those western slopes.
These Western guys, you can't trust them.
Yeah, cowboy hard hat guys, you know. They think they're out bull riding, grabbing a trunnion and trying, grabbing a drum and trying to hog tie it or something. Anyhow, so Nathan, if I push the start button, that light comes on as you saw before, but that coil isn't going to come down. But before you even know that, you have to put on your safety glasses. You know, people without glasses or that wear glasses, I probably don't say you don't have to do with safety glasses. So how are you going to prepare yourself in order to troubleshoot the circuit, Nathan? What are you going to do with the test equipment? How are you going to set it? Where are you going to hook up the things? How are you going to know that you've got something to work with? What do you set your voltmeter for?
You're muted, Nathan.
Can you hear me?
Yep.
Do you set it for the 120?
120 what?
Volts AC.
Thank you very much. Now, do you have a test meter at the plant, Nathan? Nathan, do you have a test meter at your plant?
Yes.
Is it auto ranging or manual ranging?
It's manual.
Okay. So what I mean by manual, so do you put it in volts AC or do you have to select a range? A voltage range.
Oh, you have to select the voltage range.
Okay. So if it's 120, you probably set it at a 200 volts voltage range, if that's the way it your ranges are. So okay, now that you've done that, how are you going to hook it up to the circuit before you even do some troubleshooting? You got two probes. One probe you're going to poke around with, the other one you're going to do what with?
Connect it to the neutral number 2.
Yep. Okay. So now we got so typically what I do is I take a alligator clip and tape it to the end of a probe. And then when you see the number 2 there, wire neutral 0 volt. And that's where you hook up, you can connect that alligator clip to. So let's pretend we did that. How are we going to know if that voltmeter is working or not? We normally go to a known source, right? So if
Yeah,
you're
so
going
you
to a
put your
known source,
probe
where would
on
you go to? Excuse me?
1.
Good job. And then if it says 120 volts, you're going, okay, I got something here to work with. So now I give you a symptom. Symptom is this coil right here is not energizing. It did not pull in. It did not go clock. This light came on. So where would you start to troubleshoot? Where would you put your probe at next? In order to, basically you're on a hunt and there's several things that can cause a problem. So you got to kind of put it somewhere and then go up and down the circuit from there. Where would you put it? Before you answer that question, let's
So
think
yeah,
about
you'd
this.
go down up and down the circuit.
Okay.
You first, you want to understand what's working and what's not, so we know where's the best place to start. So that light did work, and the coil didn't, right? So
Right.
we did have power here for sure because that part worked, but beyond that, we don't know because this part didn't work. So everything before this should be good. We don't need to waste time here because it got here to the light. We can eliminate all of that.
Okay.
So then we probably want to start working with this part of the circuit because there's an issue somewhere in here.
Yes. I go to terminal 6.
Okay, basically, there's no terminal, there's a 6 side of the coil. We could have put a terminal there, but there's a 6 side of the coil where the wire goes to. Show me the 6 side of the coil is, David. Or I guess I can. This is the 6 side of the coil. This is the 5 side of the coil. So you said you want to turn on number 6. Well, 6 either goes to the 6 side of the coil or the 6 side of the overload.
Oh,
You're
okay.
gonna tell me if you want to go for here or here. Which one? 6 side of the coil or 6 side of the overload?
Could you
I didn't hear that.
the 6 side of the overload?
Okay, the
The
6
6
side
side
of
of the
the overload is
overload?
right here. So that means you're putting your probe right there. On a good working circuit, what are you expecting there?
0.
0. Absolutely right. Nice job. That because but if you so now you tell me you want to put the probe there at the 6 side of the overload. That means with that other probe you got, 6 is right here. There's a little screw there. And then with your fingers, you're going to pick up the end of the probe and you're going to hold it on there. What are you expecting there? On a good working
0.
circuit, what are we expecting there? And then my question is,
0.
you're when are you expecting 0? Okay, when did you have the problem? When you pushed the button, right? So in order to
Right.
check to see if this is going to work for you, you got to press the start button, auxiliary contact closing from this point on here. So this is a little bit difficult if maybe it works that way. So I'm gonna spin this around a little bit. Maybe if you would have checked on the 5 side of the coil first, because this in itself, anything in here could cause the problem. This is the 5 side of the coil. What do you, okay, so when you push the button down, what are you expecting at the 5 side of the coil? You have 120 volts
120.
here, 120 at the 5 side of the coil. Okay. And so, and that is when you push the button down, is that correct?
Yes.
Okay, if I'm gonna do the 6 side of the overload, when are you expecting the problem? When you push
The
the
start.
start button down. You got to troubleshoot this under the condition that it's not working. And so that's why you knew to do that on the 5 side of the coil, but you had a brain fade on the 6 side of the coil. Just because it said 0 there doesn't mean you really get 0. You're not going to know if you get 0 there or not unless you push the start button here, because you've got to see what this coil is going to have on both sides. So when you hit the start button, you're expecting 120 volts here, and you're also expecting 0 volts there. But in this particular case, I'm going to tell you that when you press the start button, that you had 120 volts there. Is that a good reading or bad reading? On a good working circuit.
So bad.
You were expecting
Bad reading.
it's bad. It's bad. So if I have 120 volts there, and so we can't expect that coil there to work, we're looking for 0. In which direction do I find 0? Do I go left or do I go right?
You go left.
No, right there is it's going to give me 120 volts as well. That's going to be a bad reading. We're looking for 0. Which direction is 0?
To the right.
Okay. So if we have 120 volts here, and this is like a straight piece of wire. When you close switches, it's like a straight piece of wire. And so you got zero pressure drop across a straight piece of wire. But right now we've got 120 volts here. So if we're gonna go to the left, then you can see you had 6 right here. But there was this little white wire there on the other side of the overload right here. You can see the wire right here going to it, this white wire right there. And so that will take me to the right. That's the next place I got to do. So I'm going to check at number 2 with my meter. And so if I'm going to check on number 2 with my meter, what am I expecting there?
0.
And if it says 0, and it does in this particular scenario, it will say 0. You had 0 right here on the 2 side of the overload. That's where that is. That's their terminal number 2. So anyhow, you had 0 here, but 120 there. What does that tell you about the switch? Is it open or closed?
It's opened.
It's open. And then that means that little yellow thing that have popped out, and you push that in and away you go. Very good. Nice job. You're keeping up with things. So then basically there'd probably be a wire that fell off. Right there, that white wire there probably fell off, maybe. Out of that screw terminal. That's what we would have done in the cloud, and that's what you would have seen. And so away we go. Nice job. So from that part, we lock it out, and then we put the wire back on, we screw it down, and then you see the picture of one of Jeremy's guys pushing the start button down, and sees that the light's coming on, and everybody's happy. Okay, let's go to Jesus next. So Jesus, you push the start button down, and the light comes on, and then the light does not come on. Nothing comes on. Everything's dead. Dryer run line is off. The dryer M9 coil is didn't energize. So okay, what do I do there? And then the first thing you do is start looking around. No, look at the prints. And then from that point, you start getting an idea. What's going on here? Looking at the prints up there, and you say, okay, well, we got to start to do some troubleshooting. I'm going to use my voltmeter. What kind of voltage do I set this for, Jesus?
Set it to 120 AC volts.
And tell me about your meter. Is it a
It's
is it
auto.
a manual? It's an auto, okay. So when you look at the auto there, it's going to say like 120 sometimes, and like 120 volts AC. But sometimes I get a little bit mistaken. Sometimes it does stupid things. It gives me a little voltage, tiny voltage, something you don't even have to pay attention to. It might say millivolts. It might say 120 millivolts. You've got to look at that little MV or that volt thing at the end there to make sure you're talking about the right damn thing here. So just because you didn't put it on auto ranging or manual ranging to know that, in manual and auto ranging, it tells you if it's millivolts or volts. So that's one thing that you got to be careful of. Okay, and so you're gonna so now you got that thing set. What do you do with your meter probe? What do you do in order to prepare it for the circuit so you can do one-hand troubleshooting?
Check your known source.
Okay, but before you do that, how do you attach your one of your probes to your circuit with an alligator clip?
Yeah.
You put it on what terminal?
Put one on the neutral terminal, and then one on the hot terminal.
There you go, right next to it.
One.
Right next to it. Okay. And so that tells us our meter's good. So now we take a look at our circuit up there, and we say, well, we push the start button, the coil did not pull in, the light did not come on. You have to come up with something that is in common with both the light and the coil. So this circuit right here by itself is not in common with the coil. This circuit here is not in common with the light, but this circuit here feeds both of them. This is in common. This circuit from here is also in common, and it takes away the electrons so it can be recycled. So now that we know what's in common, then you can tell me where, and you got one of your probes here at number 2. Where should we start probing with our other meter probe? Light didn't come on? Oh, then pull in.
I would put it on the M8 drag box.
Okay, cool. You've got a terminal going, okay. The M8 drag has a 4 and 5 number to it. Well, this is 5 right here. And you can see this interlock over here has got a 5 as well. And so this is the interlock here. And then on the other side over here, this is 4 on the 4 side of the interlock. And then you can come back to terminal number 4 or 5. So should I put it at 4 or 5, or do I put it on the interlock itself, the M8?
I would put it on 4.
Okay, you put it on terminal 4. So we put it on terminal 4. Here's your probe, terminal number 4. What are you expecting there?
120.
When are you expecting 120?
What's that?
When are you expecting 120 at number 4? At right
When
here.
you press the start.
You got to remember that. You got to fix it under the condition that you got the problem. Because when you first go up there and you put it in there, it says 0. No, it doesn't. Push the start button. It says 120. Okay, so now so that's a good reading, right?
Yeah, if we've got 120 going.
Yeah, when they put the start button, good reading. So where do we go next?
I would put it after the M8 on 5. Make sure we got 120 going through there after we press the start.
Okay, so are we going to terminal 5 or are we going to the auxiliary? Are we going to this terminal number 5 or are we going to go to that terminal 5 on the auxiliary?
That terminal 5 on the auxiliary.
Okay, so if you look at that, this looks like you can put your little test probe right there. So if you put the tip of your test probe right there, what are you expecting there?
120 after you hit the start.
There you go. And so I'm saying that you've got 0 volts. What does that tell you?
And that tells me the M8 auxiliary is bad or blown.
It tells you what?
It tells me the M8 auxiliary is bad.
Maybe, because there's 2 components between here and what was a known good one. This is known bad at 0. You were expecting 120. This is 120. There's a wire and there's an auxiliary contact. Could it be the wire?
It could be the wire. Yeah.
So then probably you should go on the 4th side of the auxiliary.
Far side and then to the auxiliary. Check
Okay,
the
so
wire.
now we're on the bottom part. We got a little tip on there. We push the start button, and I'm telling you that you have 120 volts. So I got 120 volts here and 0 here. So what does that tell you?
Wait. What, could you repeat that? Yeah.
Okay, you have 120 volts here when you push the start button, and 0 volts here when you hit the start button. So what does that tell you?
So you got 120 at 4 and then 0 at the.
Yep,
At the
you have
Okay. That tells you the wire's bad.
okay, no, I'm saying you've got 120 volts here at 4 on the auxiliary. 120.
Okay.
And you got 0 there on the top. What does that tell you? 120, 0.
The auxiliary's bad. Oh.
Or that you didn't start your drag conveyor, right?
Yeah, or that.
Okay, very good. Nice job. You did a really nice job. There you go. And so, bada bing, bada boom. So now tell me, I don't think I've picked on Isaac yet. Isaac, you're gonna enjoy this. I press the start button. The coil pulls in. And the light comes on. I take my finger off the start button and they both de-energize. What's going on? What part of the circuit should I start troubleshooting?
First, you're gonna want to put your black on neutral, so 2.
Got it?
Check with a known source, so I'd
Got
say
it.
1. And
Got
then
it.
I guess from there I'd go with your switch. If your switch isn't pulling in the coil,
Okay, now the coil is pulling in. The light's coming on as long as you hold the start button down. As soon as you take your start button, release the start button, they all de-energize.
okay.
So you push the start button. So this tells you, I push the start button, my coil pulls in. That tells me this part of the circuit is good. And the light comes on. This tells me that this part of the circuit is good. So the only other part of the circuit that we haven't talked about is this one right here. What's the job of this part right here? What's the purpose of M9 auxiliary? The one that's got 3 and 4. Here's 3 and here's 4.
That's to keep your coil energized, to keep it pulled in.
That's the holding contacts. Okay. So we know that all this right here works. Everything works. But what doesn't work is this circuit of 3 things: a wire on the left, a wire on the right, and the auxiliary contact itself. Any of those fail, it's not going to hold it in.
Okay.
So this gets to be a little bit tricky. Meaning you have to kind of think outside the box here a little bit. It's almost like a process of elimination, like a short circuit. When you have things in parallel to each other, you got to quit. So we know it's a holding circuit, and so we want to prove what we can easily, and then after that we have to kind of get a little bit creative on how we're going to troubleshoot with this voltage thing here.
Hey, Clarence.
Yes.
I was just letting you know I'm still here. I just had to lay the tablet down to get internet connection.
Okay, that's mighty fine. Thank you for checking in.
Okay. Yes, sir.
Is everything working for you now?
Yes, as long as it's laying down flat, it's working. So.
Oh, you got a tough one. Good luck.
Yeah.
Good luck. Okay, we understand. Thank you. You're keeping on top of it. It's quite obvious that you're engaged. So thank you. So we have figured out it's down to these 3 here. So is there any this first wire here? How can we prove if this wire is good or not?
I'm not seeing what you're pointing at, Clarence.
I can't.
Right here. You don't see this?
I don't.
No. Are you moving your mouse around? You should be.
I am. I see your mouse. How do I move my mouse?
I don't know. It says waiting for Clarence to take over. You should just take control of it when you move your mouse. I'm not sure why it's not. If you need to click on the screen or something.
Oh, when I go,
there you go.
It's working now?
Yep.
Thank you. Okay, very good. So we got, so we know all this part of the circuit works. We saw it light up. We saw it pull in. We know the drag is on. We know all that's cool. We know that the job, the symptom is that the holding contacts are not coming in around the start button. So we know that. We know that there's 3 different things here, and we're gonna try to do things like process elimination. So first of all, let's maybe pick on this first wire right here. How can we tell if that first wire is good? What are we
Yep.
expecting at on the 3 side of that? What are we expecting on the 3 side of that auxiliary contact? Here's the 3 side of the auxiliary contact. What are we expecting there?
120
120 when?
when the button's pushed in, your start button's pushed
Think
in.
of that. Your guys are getting too automatic. Why do you think you have to push in the start button? It's got nothing to do with it. Right? Do you see that? This is a normally closed set of contacts.
Yep.
And I'm probing right here. The start button has nothing to do with that. What am I expecting at the end of the end of that wire?
Okay, that's before the start button. Okay. So it should have 120 with it being depressed. It shouldn't have, the start button shouldn't have to be in then.
Yeah, all the time unless you get the stop button pushed, right?
Right.
Okay. So you got that in your head. You have just proven that a third of this is good by doing that. Now we're down to 2 things here. Is it the wire on the right or is it the auxiliary contact? And this is where it gets tricky. It's like you're damned if you do or you're damned if you don't. If I check here for 120 volts when you push the start button, if it doesn't come this way, it'll come that way. So that's not gonna tell me nothing. If I check out the 4th side over here of this wire, I'm getting 120 volts here. Because I pushed the start button and even if this here contact is good or not. So I have to prepare the circuit. I got a little bit like process of elimination with a short circuit and got things in parallel. You start unplugging shit. If I was going to unplug something, if I was going to take some wire off, I would take it off right here. So if I took this wire off right here and put my probe there at the end of that wire with maybe with a take it off, lock out, tag out, put another alligator clip there on your other probe, your red one, put the alligator clip there on your wire. And so it's disconnected there at that time. And you're just checking at the end of the wire right there, from here to here. It's not even connected there. So now you got your meter reading there. Now if you push the start button, and if I told you you have 0 volts, does that tell you anything? Is it the wire or is it the auxiliary contact?
Well, it could be the wire because it's not getting down to your alligator clip.
So where would you check then if you're not going to do it through the wire?
I'd go to the other end of the auxiliary and check
which
that.
is the 4th side of the auxiliary, which is this guy right here. You're going to put your probe down in there with your fingers there at the end of your probe, and then you're going to be pushing the button. And if I tell you that when you push the button, it said 0 volts, what does that tell you?
That your coil or your auxiliary is bad.
Okay. So did you see how tricky that was?
Yeah. Yep.
Did you see how I at least got this out of the way in case it was that wire?
Right. Yep.
Okay. Bada bing, bada boom. Nice job. Okay, let's go with Nathan. Nathan, set it up again for me. If I hit the start button, the coil goes in, stays in, but the light doesn't come on. What do I do?
Can you
Everything works
repeat that?
fine, but the light does not come on. First thing you do is you jump on the radio, call the paving superintendent, says, my dryer run light is out. We'll have to shut down for a while. Are you gonna tell them that? Say no. Okay, so how do you set up your meter, Nathan?
You put the
AC or DC?
AC.
How many volts?
120 volts.
What do you do with one of your leads?
Put it on the neutral on 2.
Okay, okay, so.
And then
How do you prove it?
you go to 1 to see if there's voltage there. So, and you should have voltage from there up until the light, because you said that everything's working except for the light.
Uh-huh,
So you
Okay,
should
so
have
we're looking
voltage
at the-
all the way up to there.
okay. Okay, so
So
what if I said on the, so you can see the light bulb, you got a 5 there on the light bulb and also a neutral. And so,
right,
do you want to check on the 5 side or the neutral side of that light bulb?
I'd check on the 5 side.
Okay, if I do on the 5 side, say I had 120 volts, is that a good reading?
Yes, that would be a good reading.
Okay, now where do you go?
So then you'd actually go to the neutral side.
The 4th side of the light bulb, right? Oh, no, the white side of the
Yes.
light bulb, okay, yeah, you're right. You're going on this side right here. And what if I tell you, you had 0 volts, good reading or bad reading?
Hey, Clarence, so you cut out. I didn't hear you.
Okay, so I'm telling that you have 120 volts here and 0 volts right there. Is that a good reading or a bad reading?
0, that would be a good reading.
Okay, if you had a good reading on both sides and my light doesn't come on, what does that tell you?
That your light bulb's probably bad.
Okay,
Your light's bad.
okay, then immediately after you change the light bulb and you get back on the radio and tell them the plant is up and running again. Bad joke, bad joke. End of joke laugh here. Okay, moving right along now. I have a question. Are we having fun yet?
Oh, yeah.
Okay, right ends. So, now I'm gonna pick on, Earth to Clarence, Jesus. So I pressed my start button and my light comes on, but my coil doesn't. Now let's take it elsewhere. I hit my start button and my running light and my coil did not come on. What kind of voltage?
120 AC volts.
Okay, and then you're gonna hook up your to what terminal?
Hot and neutral.
Okay, and then you're gonna test it out with the other probe doing what?
With the alligator clip.
Okay, alligator clip to number 2 that will tell us that I've got one probe here. Now, how are we gonna prove if our meter is working or not? What do we do with the other probe? Just to see if our meter is working for voltage.
You want one on the hot and one on the neutral to see if you got 120 volts.
Good job. Okay, so now we have we know that. Then you can do some testing. So you push the start button, both of those things don't come on. Where do you start? Checking?
You'd want to check everything before the dryer and the light.
Okay, pick a spot.
We could probably start from let's see. Guess we'll take a look at the dryer auxiliary M9.
Okay, you gotta think about that. You gotta think about that. The only purpose of that M9 auxiliary contact is for what?
If the button's
Isaac, help them out.
If your button's pushed, pull that coil in.
Okay, the only purpose is, this comes in after the fact. This here closes only after you get this thing here to move. This thing hasn't
Oh.
even moved yet. So you can't be picking on that circuit. We've got to
Oh.
get 120 volts to this coil here, and it's not gonna go through there. It's gonna have to go through this right here. So where should I start checking?
the M8.
Okay, on the 4 side or the 5 side of M8?
We could do it on the 4 side of the M8 to see if we've got.
Okay,
power
so
before.
okay, now I got my probe. You got your probe right there in that little spot there where we can stick it in there and check. What are you expecting at M8?
We'd hope for 120.
You hope for, how about we pray? Okay, I'm praying for, okay. So yes, we're hoping for 120 volts. You're absolutely right. When are you hoping for 120 volts?
When the button's pressed.
Okay, you gotta keep that in mind. That's part of when that's part of the troubleshooting scenario. You gotta fix it where you got the problem. So I'm saying you got 0 volts there.
Okay. So you would
So if you
want,
had 0 volts there and you're expecting 120, which direction do we go?
we want to start leaning more towards the start button.
Okay, good point. Okay, here's a start button with the 3 side or the 4 side. You can see the start
We'll
button,
see
3
if-
side, 4 side.
We can put one at 3 and one at 4 to see if we've got power going through the start.
Okay,
pressed.
on the terminals could easily do that. So if we go to the so if you want to go right to the terminals, I like that because it's easy to get at. Okay, I'm saying that on 3. What are you expecting at 3?
120 at 3. And then
When?
120 at 4 when the button's pressed.
Okay, how about 3? Let's do 3. You said you're going to do 3. When are you expecting 120 volts there?
When the stop button's not stopped.
Not push. Got it. Okay. So it's there basically all the time except don't push the stop button. Good point. Good job. You're on top of things. Now you want to go to number 4. You're expecting 120 volts there when?
When the start button's pressed.
Terrific. So I'm telling you, you got 0 volts there. Not a good reading. Is that right?
Not a good reading, no.
Okay. So where are we gonna? Which direction do we have to go to get that 120?
We got to start going towards the left side, towards the start
Okay.
button.
Okay. And so on the stop button, you got a 3 side or you got a 4 side? Which one do you want to put the probe on?
We want to put the probe on the 3 side and on the start.
Okay. So this is the 3 side of the start. What are you expecting there?
120.
When?
When the stop button's depressed.
Not depressed.
Yeah, not depressed.
When you got your hands off the stop button. So we're typically, when we're starting up something, we're not hitting the stop button at the same time. So basically, in this process, it should be there all the time because who the hell's pushing the stop button down? Get your hands off that stop button. Get out of here, truck driver. I'm sure you've been through that. So yeah. So I'm telling you that you've got on the 3 side, you have 120, and when you push this and it's there, and that's good. As long as you don't press the stop button. Now you press the start button, and I'm saying that you're gonna have 0 there. When you
0.
press the start button. And what does that tell you about that start switch? Is good or bad?
It possibly could be bad if the wire going to the start is not
Okay.
good.
If this here was 0, I mean, if this was 120 volts on the 3 side, and it was 0 when you press the start button, it's the start button. Because we're expecting that 120 volt to come across there, right? And
Yeah.
it did.
And it didn't? Okay, so it would be the start button.
Okay, nice job. Okay, I'm gonna save a real fun one here for Isaac. Strap in. I'm pressing the start button. And that the coil chatters to beat hell. I don't know if you've ever heard these coils sometimes, they in the starter cabinets buzzing, but this is buzzing bad. It's buzzing back, so it's just kind of clattering along to a point where you're going, damn, I'm gonna burn up this motor and those contacts if I let this thing do this, because the contacts are coming in and out. Do we have a video to show that, David?
Yeah.
We can't hear the chatter, can we?
I didn't share the sound.
Okay. Here it is. It's not holding down tight. In fact, if is that it's going through a lot of chattering going on there. You can see it pulling in, and the light's coming on, but you can see that. So go ahead, push it again. See, it's even chattering. It's not even holding in long enough. Wow, this is gonna be a tough. I think it's your lucky day.
Yeah.
David, you want to take us back again? Thank you very much. That was good. Okay, so you press the start button and it does that damn chattering. And the light comes on. I'm pressing the start button. This thing is doing some chattering. And so that means the coil is kind of going up and down, in and out. And then until finally it's I quit. And the run light is working. So Isaac, first of all, what kind of voltage are we talking about here?
120 AC will hook
Okay,
to your neutral. Check one for a good meter. And then I guess
Okay.
I'd start right over at 5. I mean, you're getting power to the coil if it's chattering.
So where do you put your probe?
I'd go right on to 5.
Okay, go to 5. And what are you expecting at 5?
120
When
the button start button is pushed.
Okay, and you're expecting, and what if I tell you we have 100 volts, not 120, 100? Is that a good reading?
No,
Okay, so which direction is a good 120 volts, left or right?
left.
Okay, now where you're going?
I'd go to your 4 terminal or your 4 wire.
Okay, okay, so I did. I pushed the button, 100 volts.
100 volts. Okay, I'd go right back to 3.
And I'm telling you that you have I'm telling you have 100 volts. No. You have 120 volts. So you have
Okay,
100. Oh, okay. So you had 100 volts with the start button down, and you're expecting how much there?
So 3, we have 120 at 3.
Okay. Blank out that 120. So when you push the start button down at 4, you had 100 volts. Okay. And then at 3, you said you're going to go to 3, is that right?
Correct. Yep.
And what are you expecting on a good working circuit at 3?
120.
Okay. And at this point, it may say 120 volts. But when are you expecting 120 volts?
All the time at 3, I guess when the stop button is pushed.
But when are you having the problem?
When the start button is pushed.
Okay, so at number 3, press the start button and it will go to 100 volts. And you were expecting how much there?
120.
In which direction do you get a good 120 from 3?
We'll have to go to left to 1.
Okay, go to 1. And what are you expecting at 1?
120.
When? All the time, right? Even when you press the start button, put it, so we're gonna put it at 1. And it'll say 120 volts. But now you press the start button and it says 100 volts.
Okay, so we push the stop or the start button, and now we got 100 volts. So let's
That's
tell
terminal
me
number 1. Now, which direction do we go for the good 120 volts?
back to 1.
Well, we're at
Yeah.
1. So you got to go to the left of 1, right? And down
Right.
and around. Okay. David, do me a favor and pull up that picture.
Pull up my picture.
The one with dimmer.
Oh, gotcha.
Okay. You see this dimmer here. And the 120 volt cord there. That cord is plugged into a dimmer. In order to do what we did there, we put a dimmer there in the circuit. And when that happened, then when you and we turned down the voltage from 120 to 100, and that's what caused the chattering. And that's you troubleshooting it all the way back when you have the problem. And the problem is when it's actually chattering is what does it. So in this particular case, this is what caused that to chatter and that light to come on, and for that thing to not work is you had an under voltage. This is coming from your generator. Maybe you got to be turning your generator voltage up or something. So that pretty much in a nutshell takes us to where we want to be at. Is there any other things that about this circuit anybody wants to add to it? Because we'll probably take another break and then we're going to set up for doing a DC control or damper control, one or the other.
I think we beat this one up pretty good.
I think so. And you guys stuck with it every step of the way. You guys did a good job. You have a good concept. You got the fundamentals down. You're getting your money's worth out of this one. So let's maybe what time right now? What's what? Is almost 11. Let's come back at say 11:15. Okay.
11:15. Okay.
All
Okay.
right.
And
All
David,
righty.
if
We can. It's automatic or manual.
okay. And how do you normally operate it?
I usually operate it manual.
Okay. And where do you normally set your suction at?
Oh God, what is it? Usually like, depending on the tonnage we're running that day, but usually like 75-80%.
Okay, at the damper position. But
Yeah.
what does your photohelic normally tell you?
Oh God, I can't even remember right now, Clarence.
Okay, well, I'm wanting you to think about this, because not only are we, I'm going, why are we fixing this thing electrically? If you got one, if it's not working, we can help you out. Maybe automatic is a better idea.
Okay.
And then again, it gets to be when, where do you really set this at? And I know that school was that you did for the burner part of this was some time back ago, and that you have been pummeled with a bunch of information. But you guys should all take something away with on how this thing should work and where you'd be setting your the suction at the front of your dryer. And just to give you an idea what that's for, is it affects the fuel to air ratio of your combustion. It's like a carburetor on your car doing the fuel to air ratio. You just got to get it right in order it to be running the best way it can be. Now, this is a gauge that tells you about what your fuel to air ratio is when you compare it with other things. And then from that point, you go, hey, there's a better setting for that than what I've been doing. And I want you to think about that better setting. Because it's something you can easily figure out just by the way you operate your plant. And so the way you operate your plant is, well, I want to have max production with the least amount of energy waste. Well, then that means we have to have the right fuel to air ratio. Well, what is the right fuel to air ratio? Well, someone said this number here, and that's what I do. And then I go, well, maybe you should investigate why they gave you that number all along. And so that's what I'm kind of letting you know right now, that I want you besides learning how to fix this, because we'll play around with giving it problems, but why you should try to get this thing into automatic and where's the best place to have it setting at. If you look at those two needles right there, if you set them too close together, it's gonna open, close too much, and that's gonna cause some oscillation. So you gotta open those up just far enough just so that you don't have that going on. And then it finds some place in the middle. So that's kind of something you have to adjust for a little bit when you're thinking about putting this thing in automatic. If it overshoots, then kind of widen them out a little bit. And just gonna bring them in a little bit at a time until you find your right spot. But then you're going, what is the right spot? And this is a very important adjustment. And if you remember the burner tuning up part of this workshop that we were talking about, you had to adjust the fuel to air ratio, and that the damper cell has something to do with it. And then the burner control part, typically I would always be just telling people about the story about going out to a plant and doing a burner tune-up. Well, before I even put my analyzer on the stack, I just went to the control room and did a burner tune-up ahead of time before I did a burner tune-up with an analyzer. And that is to find out how they're operating their plant. And so are they operating their plant efficiently? Well, how do they know that? Well, when I got there, all I did, I said, I'm not going to touch anything you're doing. You've been going along this race smoothly all the time. I'm not going to put my analyzer on. I'm just going to see if I can get more BTUs out of your fuel than you're getting right now, just by the way you operate your plant. And it was simple. And I increased their production about 8% just by making an adjustment. And that adjustment is that open close switch. Or I open it up. So all I did is open it up a little bit and the temperature of the mix went up. And so I'm going, he didn't, all that happened is we gave him more air. We didn't give him more gas. So, this is a big energy saving thing just based on the way how you guys operate your plant. So keep that in mind when you're adjusting this thing. What are you really doing? You're allowing the flow of air to go through your combustion chamber in order so that you get the heat out that you need. And if you're choking it up too much, that means you were too rich before. And you needed to lean it out a little bit. But if you don't be making these adjustments, you're not going to know that. So try to keep this in your head a little bit and watch that mix temperature as you are adjusting that. Then that you go, that looks like maybe the best place for me to be putting it, where the certain section area that you see on the indicator there. So by trial and error, you can make your plant run better than it has, FYI. So I'm just giving you an answer. I'm trying to get you excited about wanting to fix the one you got. Now, some people are controlling their airflow with a damper, and some people are doing it with an exhaust fan. they increase and decrease the speed of the exhaust fan. And so with a VFD typically. And so anyhow, this photo here could be set up to that as well. To say, okay, you're a bit too low, bring up the speed of your exhaust fan. Oh, you're a little too high, bring it down some. So just to let you know what that's all about.
So
And sometimes, go ahead.
I have a question. We have a damper as well, and sometimes the temperature is too low, so I would close it. But once I made the right adjustment, sometimes it'd still move up or down. I wouldn't stay at a certain range. Could there be a
Okay.
problem here?
Steve,
Yes,
feel free
Nathan.
to
You
weigh in.
You could have a problem on your actuator. It may be getting weak, where you adjust
Well,
one way and it doesn't hold
okay, because
on
our
the Venturi itself.
actuator, right, our actuator had actually went out.
Okay.
But
And
before that, that's what it was doing. It wasn't staying at a certain range. It was just either going high or low, and then finally it went out. It wasn't
okay.
opening or closing.
It was just flat wore out. Yours
Okay.
on yours is actually operating a Venturi. Same
Right.
thing as a damper. And you're narrowing up to increase that airflow past the water sprayer through that water spray. And it probably was just the poor actuator got wore out because you'd move it up there and it'd creep back or whatever against the force of the air.
Here's what I could suggest to you guys, and without getting too much into this right now because we're going off course, but I do want to reiterate that if you guys do have problems in the field, you know, especially Jeremy and Steve on things, Dave as well, is that they can help you go through and troubleshoot installing one like over the phone and over Zoom or something like that in order for, these are the kind of things that should get fixed. So if you got nobody else to go to, you can go to these guys. But if you start getting too lengthy, I encourage them to bill you for it because you're doing them a hell of a service. So keep these guys in mind for someone that knows what is going on with you guys, because they have a pretty good idea now about your plan. You got a scrubber, you got this, you got that. And so, and they've been around. So if you need help as you're going on, feel free to give them a call and tell your boss you're going to and say, hey, look, these guys do some consulting and they can keep me out of trouble. And so we'll give you some good information. Anyhow, I want to kind of leave it at that. Is that, first of all, the gentleman that has spoken, I would say get your actuator working and then work with Steve on that, because that's in his background and the kind of stuff he does. So I want to leave it at that. Is there any but I'm telling you what I want to leave you with before we go to the electrical is that as you're adjusting your air up and down, look for the highest mixed temperature you're getting. That gives you the best indication you possibly can for the best combustion you can have at the settings you have now. And that is that's an easy adjustment right from your control panel. And you can be watching your instruments. You want to be instrument rated. So pay attention to these instruments. Why are they there? What kind of stuff? Go back to your books. And if you got some questions, pick it up and you call Steve. And if it gets to be too much, he's going to bill you. And so, but it's a fair, anyhow, that's where I'm at. So moving right along now. If we had a knob on this manual automatic switch there, it would either choose one or the other. So one's going to be automatic and one's going to be manual. Well, this is the manual thing right here. Okay, you open and close. It's spring loaded. If you go to left, it goes the windings for the actuator will have 120 volts there. You go to the right, 120 volts will go to the actuator the other way as well. as you're opening and closing, there's a potentiometer. Remember that pot, that resistor that had a wiper into and then 2 leads at the end? Well, you know, this is the same thing here, is that we took that wiper and we attached it to this meter, and the more we open up that wiper, the higher this here goes. And so we got that, and that moves like on a 360-degree thing. Well, that's inside your actuator. They got something like that, a slide wire like that. That is when it goes open and close, the resistance is going to change. And that voltmeter, which is a DC voltmeter. So we got 2 kind of voltages in here. We got AC and we got DC. And so then we got these lights here. This is okay whenever we ask this thing to close. This here light comes on whenever the close windings comes on. You go to open, this green light comes on, da 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 da. And then so that's how a damper control. So that's moving that damper. That's giving it more air to more air for your fire or not. And so you should be paying attention. The more suction that you have, the more you open up your damper, the more the suction is going to go up. And then, but let's go back to that one gentleman. He was saying he was having a problem with his damper, and that right there. Before going, I want to talk that process a little bit more. Actually, it's worth you bringing that up with Steve. Steve, if in your chat box, why don't you give him your phone number and talk to him a little bit about what he's got going. That's what I do. Anyhow, so I'm going to continue with the electrical.
Nathan, you already got my email.
Yes.
Okay, good enough. That's all you need. And this is continuous improvement. It's training. Steve's been around for a long time. So now we're looking at the back of this photohelic, and so or the back of the cover. So you're seeing the back of the cover where we got the lights, we got some terminals there, and so we can poke at the terminals there right on the light bulb when we get under those connectors. Well, you can see the backside of that meter. There's just 2 wires there. Then you can see our automatic. Then on the left side there, thank you. That's going to be our open close switch. Yeah, keep it. That's your open close switch, and you can see that we've got some contacts in there, and the contacts at recess are both green. That means they're both normally open contacts. So whenever he goes in one position or the other, as far as closed or open, one of those green things is going to come up. That's a normally open. That's going to be closed, which is going to give us 110 volts going to our going to our actuator. Excuse me, earth declarance. And so then you see on the we've got the manual automatic switch there, which is on the far left, with its operator missing. Depending on manual automatic, depends on what the circuit's going to be doing, but it's going to be picking or choosing one of 2 things. It's going to do that in manual, you're going to do the close open, and automatic, you're going to do that photohelic. And that photohelic is that it's going to close or open some contacts whenever actually it's to close some contacts whenever that needle gets on one side of one or the other, to try to keep this thing balanced, to position your damper for what you need to do. Now, sometimes, and Steve can help you determine this, that if you have like a Duff Norton, sometimes those things overshoot. Well, there are things we can do to keep it from overshooting, but having this thing working automatic is really a good thing. You should not have to be babysitting it, and you should be knowing where to put it. So take that home with you. If you guys don't, if you have trouble keeping up with that, give Steve a call. Say, hey, I want to know how to operate my damper. But I want to fix it. So we get that manual auto switch taking one or the other. So then you're seeing that in the back. You're going, well, the automatic part's that photohelic up there, And that photo helix there kind of got some wires running all the damn place. Saying, holy damn Toledo, what the hell's going on there? So from that point, what you don't see now is it also has a power supply that we feel a DC power supply. We take it from AC to DC. And so that's the power supply there. It's red, and then we got a potentiometer. You see the pot, and it's got the wipers in the middle, and that slot screw there. It turns like about 340 degrees. So if you can get an idea where it's sitting at on the voltage, is probably sitting at your DC controller or to our, in this case, it's a indicator. You can see the terminal numbers 1, 2, 3, 4, 5, 13, blah, blah, blah. 21, I think, in these. What's the other one? Anyhow, that's what we're dealing with right there. She's a good looking circuit. So now I'm looking for probably a schematic with maybe the backside of the front cover is where I'd go with on that.
Clarence, I have a question.
Go for it.
So our damper switch that opens and closes it, it's in the same box as our burner control panel. Well, what type of circuit would that be?
What I would do is I'd take a picture of any burner control things you have, and also of your front panel, where your burner control thing is. Is it a Hawk or what kind is it?
I'm not sure. I had showed it to Steve earlier.
Okay. I'm sure Steve, Steve can walk you through that. He knows how to troubleshoot that stuff. He's your man. So what was your question?
I was just wondering what type of circuit that would be, because I noticed that this one is in its own control box.
Okay, Steve could answer that question for you if you want to get back to him after the classes are over. How's that?
That'll work.
Okay, because you've got a lot to do with your damper control. You guys might as well bring yourself up to speed. You can save a lot of money. I mean, a lot of money. And also the greenhouse gases. You're bringing them down. There's nothing wrong with that. Cool. Okay, so here's our schematic, and there's your actuator. And your actuator, that potentiometer that is there down below, way down below, that's actually located inside the damper drive motor. So I don't know, can you guys see my my arrow moving? You are okay, so can you guys see this now? My arrow?
Yep.
Okay, this is a potentiometer. This is going to tell you where the hell you're at. This is actually located inside this box right here. So if I would have drawn that out correctly, I probably would have stuck that in there, but it was difficult for what we're doing here. So anyhow, this works. But anyhow, whenever you do an open close here, this wiper moves back and forth here, okay? And that tells you where position is. It's always nice to know the position of your damper, especially when you're starting up and making sure that it is open for being purged. Anyhow, so now we're looking at some of the switches we had on the front. We've got the manual auto here, and we got the open close. So here's the manual auto. First of all, it gets its 110 volts. It's going to choose if you're going to go automatic or manual. So this is a or thing. You're either in this position or this position. It's either the photo helix switches take over or your open close switches take over. And what are we taking over? We're taking over the open close windings right here. And when these open close windings here move, so does this pot. And when that pot, so does that indicator on the damper thing there. So this is a pressure switch. That damper thing is a vacuum switch, basically. It's a very sensitive one. And there's 26 inches to a PSI. And you guys are looking at like a tenth of a PSI, a tenth of an inch of water column when there's 260 in a PSI. So it kind of gives you an idea what kind of sensitive at a tenth and 0.1 and 0.2 and 0.3. So it's sensing the suction at that point. This is what's allowing all that air to come in. So this is really a very important instrument. And you should get it going. And so you got a so that's a vacuum switch that what that photohelic is. And so and that means the higher the vacuum, the more that when it gets to its set point is by the red needles in front. When it gets to set point, it's going to flip over. So that so if you notice that the open winding, if you look at the open winding at number 2 there, open winding up here, thank you. And then I go to 20, and it comes with here's open. That means this is going to get 120 volts when we're asking it to open. That means it's not getting enough suction, and so it's going to allow it to keep it open until it gets enough suction. And now this is the closing one there. If you follow that one back, 3 down this way, this is the normal one for close. It means I need, if I get too much, I'm going to want to close. So so if you're have your set point at 0.1 and you have it set at 0.2 and it goes past 0.2, it's going to start to close it because that thing just did its thing. So that's how that works. And so now you got that switch up there for manual. So that's the automatic part. Here's the manual part of it. This is whenever we switch into manual, we're notice the XO and the OX. What does that mean to us? Well, that means that top contact, when it is in manual position, that happens to be closed. And if you look at the one below that contact, when in the manual position, now it's open going to the photohelic. So that says, okay, I guess we want to have 120 volts going across that top contact to switches in parallel. And this is a spring-loaded switch, and it's it means that in the middle it's off. We don't want nothing happening. Notice that the OOX and XOO, it's OO in the middle, meaning that there's not going to be any damn connection. Thank you, David. And then so and then if we go to the top connector, the top contact, then right here we're going to see that it says OOX. That means when you do your spring loader to open, it's going to 110 volts across here. It'll go to our terminal number 20. 2 will get it. We got 0 at neutral, and it's going to move. And then you let it go. It's going to go back to the middle. And you go, oh, I want to close it. Then you go to the close. And then we have XOO, and consequently, we're going to close it. So it's really pretty simple. High pressure seek low pressure. This is 120 volts seeking neutral. Oh, look at this power supply here. We have a plus DC voltage, like 12 volts. We'll call it 10 volts. This is 12 volts. What the hell? So we got high pressure seeking low pressure. Same thing's over here. So it's going to be pushing some electrons through there. That means that so if we check from number 2 to number 1, and now this is polarized. This is something we're playing with our DC motor now, and or a DC power supply, DC voltage. So consequently, you're going to want your meter set at for voltage. If you have a manual ranging, ours are manual ranging. That's going to help. That is a 20 volt range, and then you can see from 10 volts to 1 volt what's going on there. That's how that's going to work, and we get a true side of the there for power supply. You just take your DC black lead. Now this is polarized. Yeah, this is volts DC, and you're taking your black lead and sticking it to number 2 terminal. And so now you know what's happening there to number terminal. And then you can probe with the other guy. And so if you probe from 2 to 1, you're going to see it's going to say 10 volts. And so from this 2 to 1. So now I'm gonna leave my meter at 2. If I check over here, this terminal 4, I would expect 10 volts. And then if I check at the wiper here, I would expect, well, I don't know, where's the wiper set at? If the wiper set all the way to the top, it's gonna be 10 volts. If it's set all the way to the bottom, it's gonna stay 0 volts. If it's in the middle, it's going to be saying 5 volts. It's gonna report that to this indicator that says 0 to 100 whenever you give this a full 10 volts or 12 volts. It's just set in the middle and you go, oh, okay, I know where my indicator's done. So that gets to be a troubleshooting scenario all on its own. I think that pretty much covered that. So let's maybe start picking on somebody. Let's go in alphabetical order with Isaac. Oh, did I make that up? Isaac, symptoms are, David, can you give me it from,
Yeah, you.
The,
I think you just have to click. When I had to let Nathan in, I think that you just have to click the take back.
okay, is it possible? Okay, yeah, I'll leave it right there. Let's see what I can do. If you remember, we have that open close switch and we have that photo helix there on top. And we got the indicator here. And then we've got our, this one right here was open close, and this is manual auto. And I'm saying that when you're in the manual position, it does not open. In automatic, it opens. It does in automatic or manual, it does not open. So is this so where will you set your meter to, Isaac?
You're gonna set it to DC.
Okay, that was for the indicator. Now, you can't expect this thing here to move unless this is gonna move you. And the symptoms were, whether I have this in automatic or manual, I can't open this. So, let's kind of see what does work. Well, so it opens, but it doesn't open, but it will close. Well, if that's the case, all this right here we know works in automatic and manual. So this is the part that we know works.
Okay.
So we can now start picking on the part. Now this is what we're looking for, 110 volts here. High pressure, 6 low pressure. I mean, high pressure, 6 low pressure, and so we're looking to get to this to the number 2 with our high pressure. We're expecting what there when we open up that circuit, or we open up that winding. What are we expecting there?
You're gonna be expecting 110 volts, right?
Right. Okay. Based on that, the fact that you have put it to 120 volts and put it on number 2, and you checked your meter, and where's your first next or where's your first check?
Ooh.
Now, Jeremy, did you warn him about coming up with bullshit answers?
No, I did not warn these guys about you calling them out if they give you a bullshit answer.
Okay, Isaac, don't give me no bullshit answer.
Yeah, that's why I'm not answering.
Now, don't be scared. Just
I'm not scared, but
Isaac, are you a married man?
I'm married with 4 children. Yes, I'm
Okay,
married.
okay. It understands your demeanor then. Okay. Okay. Well, okay. let me say something. From here to here, all that works. From here to here, that works. So what's in common with both of these is this switch here, and both of these is this switch here, and this one here works, and this one here works. So this part of the circuit works good. And so you, first of all, you're going to decide if you're going to troubleshoot this in automatic or manual, because you're going to have to do some testing, and it really doesn't make any difference which one it is, as long as you know how to flip the set points and stuff like that. So do you want to troubleshoot this with a photohelic, or you want to troubleshoot it with a switch?
I'd say troubleshoot with the switch.
Okay, let's do that. So now we got it isolated up there. We also have it isolated on what part of the circuit works. We also have our voltmeter all set up and ready to go. Where's your first probe?
So I guess I'd put your first probe on the switch.
Okay, what part of the switch? On the left side of the switch or the right side of the switch?
The right side of the switch.
Okay, very well. If we're going to look at the right side of the switch, we're going to be going down to, so this is the automatic manual. That's this one right here, okay? And so we got a number 20 there, and that one there says 21. So this one here is 20, okay? So if you want to physically see where that's at without being there, you'd put a probe on that screw there, and you would be putting your other alligator clip on neutral. And what are you expecting there? Because that's where we're probing right here. What are you expecting there?
110.
And then my next question is going to be what?
Where we're going to probe next?
No, when? What are you expecting? You're expecting 100.
When your switch is closed.
Bingo. Okay, you gotta you have to continue to remember that. It's one of those things that's going to help you out a lot. Okay, you got to troubleshoot it when you're having the problem. You're not having the problem with it in the opposition. You're having a problem in the closed position. And I'm saying that you have 120 volts.
Okay, and then we'd probe on the other side of the switch.
Okay, you've got your 120 volts there. It's 120 volts come from here. When you went to close it, you had your 120 volts. Was that a good reading or bad reading?
120 would have been a good reading.
Okay, so where are we going to make our next check?
God,
Okay, you've got 120 volts there. You're trying to get 120 volts to this open winding, right?
Right.
So it will do its thing. So you got it there, but the end result is it ain't opening, and we gotta be doing some checking to make sure we get 120 volts there. So you got a choice of going here or here.
Okay, yeah, I'd go to 20 then. That'd be
okay. Okay, and I'm saying that you have 120 volts there.
Okay, then
and okay, my point there should have been you have 120 volts here, and then I should have said when.
When
it says when you're
closed.
Very good. There you go. Okay, so now when closed, you have 120 volts there. Where do you go next?
To 2.
Okay, now we're at 2. What are you expecting there?
120.
When?
When it's closed.
Okay, I'm gonna ask you that question again. What are you expecting there?
120.
You got to finish it up. You haven't finished it up yet. That's a 2-part statement.
When it's open?
No, 120 volts when pushing the close switch. That's the answer.
Okay.
Well, one more time. What are you expecting there?
120 when it's closed.
There you go. Okay. You got to make that connection. Got it. Good job. Very good. Thank you very much. Moving right along now.
I have a small argument that this was a wasted check because it didn't work in both positions, and that isn't common to both positions.
Yeah, I hear you.
But other than that,
Yeah, thanks for pointing that out. There's points of this where, at Terminal 20, they both didn't work, so at Terminal 20, that would have been, you would have had 120 volts. But two, if you had it off at 2, so what are you getting at, David?
I'm just saying it, unless these are both off, that wouldn't have been, that doesn't affect both of them, right? If this wire was off right here and he wasn't getting 120 through the switch,
Okay,
that wouldn't have,
this
that
wire
wouldn't have
right where?
affected
This wire right where?
where I was just pointing. If it was coming through, if it wasn't coming through right here, that wouldn't make it not working automatic.
I'm not seeing you. Okay, now I am.
If it wasn't coming through the manual, that wouldn't affect it coming through the automatic, but both didn't work.
True, good point. So you're saying that first one may have been more of a wasted check because it wasn't in common with the photo.
Right, that shouldn't have been the starting point.
Okay, okay. So all in all, it got you there anyhow. But when it comes down to trying to troubleshoot with the least amount of checks, David's absolutely right. So I suggest you don't play chess with him either, because he pouts if he loses. Bad joke. Okay. No, that's very good. So next problem. It works in manual. It works in manual just fine. In automatic, it is going to open all the way and it just close. Okay, manual. Okay, so another guy I'm going to pick on Jesus. Lucky you. It's your lucky day. In the manual position, maybe put this in manual, it will open and close just fine. So this all works here just fine. Tells you my open close switchers, it opens and closes the windings, switches work just fine right there. Everything all the way through this here is good. But I'm finding that when I put it in automatic, no matter where I put the set points, those needles, those red needles, it opens all the way. And no matter where you put the needles, it won't close at all. Can we pull up that drawing the front face? Easy enough.
Yep.
Okay, these needles right here. In manual open and close, it works fine. Lights come on, life is good. The position indicator goes up and down. But when I put it to automatic, then this is supposed to take over. That's what this here is. And so, so basically, running like this, about this distance of it, if the needle comes down a bit too low, it's supposed to open it up a little bit. If it goes a little too high, goes down a bit. You got these set too close. Sometimes they'll overshoot with each other. And you're trying to slow down that actuator movement, it's moving too fast. It's kind of the idea. So it works open and close manually. This is just fine. This here works just fine. But when you put it in automatic, this here needle just drives all the way up, no matter what. It goes right past that one and doesn't do any closing. It will open all the way up. So this will open up all the way, but this here will not close. So that's what we're stuck with when we put it in automatic. And it says, well, that ain't gonna work out. And so we do some troubleshooting. So who was I picking on that one? Did I mention?
I think you're on Jesus.
Who?
Yeah. This
You're
guy.
picking on Jesus.
Okay, Jesus. So basically what's happening, this here works just fine. But when you put it automatic, if this open winding here is going all the way open and just and it just stays open, and the open light is on all the time, that means we're getting 110 volts there. We're getting 110 volts from this guy right here, and then it comes across there, and this is this is that first red needle. This is the one that says, okay, I'm not getting enough, let's open up. This right here. That's what that needle is right there. And this here needle is this guy right here. Well, this one right here says that no matter what that about where I am with that needle, I'm gonna keep that close. I'm not gonna move at all. I don't care if I'm above it or below it, I'm not gonna move. And this one right here says, I don't care if it's above it or below it, I'm not gonna move either. Both of these are not moving, is what the hell is happening. And so the set of contacts continues to put 120 volts to that. And just as it drives all the way over. So you come up to this one right here, and this one here doesn't do its job. So we got to find something that's in common with both of these things on why the damn things aren't working. So if you look at that from objectively, what kind of things are possible there? I mean, all this here does supply 110 volts to it. It's these things right here that aren't tripping. So what else do we have in common with this? See, this is an electronic pressure switch that you have here, and it needs power too and stuff like that. And in order to get these things here to move. So what is in common with that photohelix there that is affecting these switches from not operating? That's what's happening, they're not operating.
The auto position, I'd say.
Okay, I would say that's a good, that's out of position is about one thing that you would go to, you're going, what else could it be? But all we're doing is providing 110 volts at both of these terminals that give us this and that. So that really, it allows it to, if we didn't have 110 volts, then nothing would work. So I don't know if I would pick on that, but if we go around the circle, we're gonna say, well, here's a normally open, normally closed. I'm not sure. And so if I get 110 volts here, that means that this is telling me to do it. There's nothing wrong with that. If I get 0, that tells me what it is. That's not really anything wrong with that. But if you keep on coming, you look at L2 and L1. What would L1 and L2 have to do with that? That's 110 volts right there. What would that have to do with that? Well, this is an electronic pressure switch. Means that it's going to have a power supply of sorts there in order to make that electronic stuff to work. And if we don't have 110 volts going to that power supply, we can't expect it to work. Just like this power supply here. We can't expect this here to work if you don't have power to it. And so if it doesn't have its L1 and L2. So basically what I would do is, and so you're looking at this. So let's start out as if we were going to do some troubleshooting. Is the part of the circuit we're having a problem with? What would you set your voltmeter? What would you set your voltmeter to?
I'm pretty lost.
Okay. Well, the fact that this photohelix thing here is right where it's at. And this is a difficult question. So there's no
Would you jump to the 12 DC that's down there on the bottom?
Well, this photohelix that does the switching has got it only has 110 volts going through it, the photohelix.
Okay.
So we're going to just deal with 120 volts. If I was dealing with the indicator, then I'm going to start looking at the 12 volts, but we're not in that part. Our problem is up here. Our problem is that this thing is not switching, and it's causing this thing to go open all the time. Manual circuit part works right here, but this is not switching like it's supposed to. What would keep that thing from switching? Well, this is like any other component. You need 120 volts on one side and 0 on the other. So since we're troubleshooting this, what would you set your voltmeter to?
120 DC.
Okay, And then what would you do with one of your indicator leads? I
You
mean,
put it on the main
your meter leads. And right here, okay? And then what would you, and then now I'm telling you that on this thing right here, this is like a component. In order for this thing to work, and it's not working, it needs to have its proper inputs. And part of those proper inputs is L1 and L2. So if you had one of your leads in at neutral, what would you do with the other probe? Put it on L1 or L2?
I'd put it on L1 to see if
And
you
what do
got
you expect?
power.
Was that
You'd want to see power 120 DC going through it.
120 volts? What? AC or DC? We're talking
DC.
AC.
AC?
Yeah.
Okay.
Okay. When you see 1 and 2 like that, that's a term like that. We're talking AC. So these are your actuator that opens and closes 120 volts AC. And we're just kind of doing some switching to and from the thing. And right now we says, okay, we got to make sure we got power to this photohelic. And you're telling me that you need 120 volts. And I'm DC, but it says, no, it's AC. So 120 volts AC, is that right?
Yes.
And when are you expecting it there?
When you're in auto.
No, all the time. Look at the line. That tells you. That's number one. It's got power there all the time, right?
Yeah.
Okay. So when I ask you, when are you expecting it L1, you're expecting what?
120 AC there.
Okay,
all the
when?
time. All the time.
Okay, I'm gonna ask you again, but I want you put those two sentences together. You're expecting what there?
120 AC there all the time.
Good job. Okay, so we nailed that one pretty good. We nailed it pretty good. Nice job. Okay, let's pick on somebody else here. Let's pick on somebody here about that that indicator down below there. I think you know who Isaac here. I think is it Isaac? Are you up to bat? Or is it Nathan?
I think it was me, Clarence.
Nathan?
Yes.
Okay, Nathan, you're up to bat. So here's our meter. If you guys can see my arrow moving back and forth
Yeah.
on the photohelic. Okay, so as we're opening and closing in manual, when you have this in manual, this indicator is supposed to go all the way to the top. And then stop, and then you can back it out and go maybe to the middle. So that's what we have there, is this little pot. Remember that the slide I was talking about? And what kind of actuator do you have on your plant, Nathan? Is it a long skinny one or is it a square box?
We might have lost him again.
Okay,
Just frozen.
well, hey, let's do this. I think this would be a good time to take a break. Why don't we do that and come back at 12:45? Do that?
Okay.
Okay. It's break time, 12:45.
Lunchy.
Yeah.